Okay, so this is final for Q1. So first we start off with the free body diagram. So we got S. And over here, it'll be Fn. F of G in equal length. And then T. And then for H, it's T in the up direction. And then F of G, which has to be longer since it's decelerating downward. Okay. And then we have an expression for acceleration. So first I'm gonna set up net force. Oh shoot. So I'm setting net force for H first, for block H. And that's FGH minus T equals MA, little ma. And then, so it simplifies down to MG minus T. You can expand that. And we don't know what T is, so I'm gonna set up net force for block S. That's big MA, T. And then the only T is acting on it, so or Fn and Fg cancel out, so it's just T equals big MA. We can plug that in here. And then get both A's on one side. And then factor out an A. And then we get A equals to mg over big M plus small m. Oops. So next is C. We're trying to derive T. So I'm gonna set up net force again. So net force of H equals small ma. So FGH minus T equals ma. It's time we're solving for T. So T equals ma minus FGH. So that means T equals to mg minus ma. Okay. So for part D, increasing the mass m will increase the, actually I'll do that other one first. So it'll decrease the acceleration and increase tension. We know this because we can use the expressions we derived earlier. So A equals mg over big M plus small m. Using this one, we see that when we increase the big M on the bottom, the denominator will be bigger, which decreases acceleration. And then we can use the net force of S, block S, capital M, and that would be T equals big MA. And we see there that when we increase mass M, it's multiplied with A to get a bigger tension. So acceleration will decrease, but tension will increase. Tension T. Okay. For E, I'm gonna set up net forces again. This time we have friction, so net force of H equals ma, and that just still be FHG minus T equals ma since it's floating. Or not floating, but it's hanging. So mg minus T equals ma, and I'm gonna solve for A and set them equal each other. For T and set them equal each other. So this is I'm setting the force of block S now. Boom. So T minus Fk equals Ma, and then T equals Ma plus Fk. And I'm going to expand this to T equals Ma plus mu k Fn. And then that's T equals Ma. And because the block is resting on the ground, or it's moving along the ground, with no force acting in the y direction, aside from Fg and Fn, Fn will equal Fg. So you need to make it a big Mg. Sorry, I'm just gonna, I'm not solving for T, I'm just gonna plug it in. So Mg minus Ma plus mu k Mg equals Ma. And I'm gonna distribute the negative sign, minus Ma minus mu k Mg equals Ma. I'm gonna get the Ma on both sides, on one side again, so that's mu k Mg equals Ma plus big Ma. I'm gonna factor out the a's again, so A equals, so A m plus big M equals Mg minus mu k big Mg, and A equals Mg minus mu k big Mg over M plus that. Okay. Now F. So our expression for T. So once again, I'm gonna set up net force. Net force of H equals Ma, and this time I'm gonna solve for A, and then set them equal each other. So Fg H minus T equals Ma. Mg minus T equals Ma, and then A equals Mg minus T over M. So now I'm gonna do the block S, big Ma, T minus F of K equals big Ma, T minus mu K of Fn equals Ma, T minus mu K of big Mg equals Ma. And here A equals T minus mu K big Mg over big M. And I'm gonna set these two equal each other. So then Mg minus T over M equals T minus mu K big Mg over M. And then we're gonna cross multiply them. So then M times T minus mu K big Mg equals big M Mg minus T. Distribute both factors. It's M T minus mu K Mg. Oops, forgot the M. Boom. Big M small mg minus big MT. We get the t's on one side. MT, I'm gonna add this one over. So I'm gonna add that one over. So plus big MT, and add the other negative sign to the other side. So it's M mu K mg plus big M mg, and now we can distribute, factor out the t. So plus M, we organize this mu K g plus M mg, and then we finally get t equals M big M mu K. I mean, not mu K, just we have mu K. Not bad. BKG plus big M mg over M plus M. Okay, good. Now G, so with the friction present, tension will increase. This is because without friction, the net force for block S is just T equals MA, but then with friction, the net force for Fs becomes T minus F of K equals MA, and T equals MA plus Fk. So assuming that the acceleration and everything else is held constant, in adding friction will actually increase T. So therefore, more force is needed to pull a system with friction added, which results in a bigger T tension. Okay. Now the net force is for H. Okay, so I'm gonna do block S first. So the dot here. Actually, I'm gonna draw a free bar diagram of a square this time. So this is block S. So you have F of N and equal F of G. Tension pulling it to the right. And then we have F of K acting against the line of motion. And then we have F of the contact force of the small block onto the big block. Okay, I'm gonna do the small block in front of S now. So it's small block of M. It's an F of N, so on the ground, and an F of G equal value. It's not touching the ropes, there's no tension. And there's still an F of K because it's getting moved. There's a part of the amount of motion. And then here, it'd be a contact force going this way with F, and this is the big block acting on the small block. And finally, we have block H. This one's the same, it's just tension and a greater F of G. I. So since the rope is not touching M, we can just make this one big mass. That's not what I meant to do. One big mass. I'm just gonna make it all like the mass of block S. Okay. So then using the formula we derived earlier, A equals mg minus mu k, big mg over m plus m. And we just plug in all the values. A equals, so then big M is 3. Oh, that's small m. Oh, that's small m. Wait, it is, right? Oh, it says it. Yeah, that's small m, 9.8, minus the mu k, 0.18. And then for our big M, we said that block S would be the combination of both of these blocks for the mass. So it'd be 3 plus 2. And this time times 9.8 for gravity. And then on the bottom, it'd be small m plus big M, which is 3 plus 2 plus 3. And this all simplifies down to 2.5725 meters per second squared. Time for J. Calculate tension in the string. Once again, we can use the formulas that we already derived. So T equals big M mg plus M mu k big mg. over m plus m. I'll plug everything in now. So big M is 2 plus 3. Small m is 3. Gravity number 8 plus 3, 0.18. 2 plus 3, and then 9.8, all over 2, 3 plus 2 plus 3, and that will get us a total tension of 61. Oops, I read that wrong. 21.6825 newtons. It is right. Okay, it wants to calculate contact force between two blocks. So I'm just gonna set up net force for S first. Goes big MK T minus FKS, and this is this is the block, just like the big block, not the two blocks together for FKS, and then there's a minus FM M plus MA. So then I'm gonna solve for FM. So I'm gonna move both to the other side. So it's MA plus FKS minus T. And then when we divide by the negative, we get MA minus FKS minus T. Oh, negative here, my bad. Plus T. So I'm gonna expand the other side and reorder it as well. Minus MA minus is mu K Fn, and we know Fn is mg. T minus MA minus mu K big mg. Okay, and from here we need to plug in all the values we know. So we already solved for tension, and it was 21.6825 minus big M, which is 2. And then we found acceleration earlier to be 2.5725 minus 0.18 minus 2 minus 9.8. And we get F of the contact force to be 13.0095 newtons. Okay, L next. If the system starts at rest, speed. So you set up a velocity, set up a function, physics function, Vfy squared minus Viy squared equals 2a delta y. So the system starts at rest, so we know that Vi squared is 0. We found acceleration to be 2.5725. If you know the distance from the ground, from the block to the ground is 20, so just put that in here. Okay, I guess, yeah. Okay, and then we square both with the V square both sides, and so then Vfy equals to 10.144 meters per second. I should have Vfy. So now it's M. Calculate time required. So now I'm just gonna do delta y equals Viy t plus 1/2 at squared. This is 20 equals, set at rest, 0 plus 1/2 of 2.5725 t squared. We get t squared equals to 15.4549. Let's square that. Square root both sides. We get t equals 3.943323 seconds. Lastly, n. sketch some graphs. First is position versus time. Boom. So be position t versus time. Position v time, and this would be y in meters. And then, so I'm just gonna do all. I'm gonna draw out all the. This would be in v in meters per second, and time is done seconds. What's next? Speed. V time is t seconds. Speed meters per second. Acceleration. This is time. And then this one would be a in meters per second squared. And last but not least, net force in newtons, t seconds, net force v time. Okay, so I'm gonna switch to my red pen to draw out the lines. First, position versus time. When acceleration is constant, it's gonna go like this. It's positive, so concave up. Next is velocity versus time, and we know that it just increases since acceleration is a constant. For speed, it doesn't cross the x-axis at all, or it doesn't go to the negative side, so it's just the same thing. Boom. Acceleration, we said it was constant. There's a line. And net force, like this, and then it will just drop down to 0 once the ball hits the ground. Once the block hits the ground, net force will equal 0. Thank you.